So you can't go very far researching in the blockchain space without finding about Elastos. Elastos has always been in the back of my mind for the longest amount of time. It's, being touted as an operating system, the new internet for the smart web. These words are huge, but exactly what do they mean? And as I dug further, it intrigued me how different Elastos is from, say, Ethereum. And as a platform, the psychology behind that is extremely different. In this video, I had the pleasure of interviewing two core members, Ron and Kieran, and we chat exactly about how Elastos works behind the hood. To give you a taste about what's very different about Elastos, we must compare it to something like Ethereum. Ethereum is one world computer. It has the same state shared across all the machines. But Elastos is very different. It divides all these machines up into their own virtual machines. That's done to preserve a lot about user privacy, and we'll go into a little bit detail about why this is very necessary for the future of decentralized applications. So I hope you can learn a little bit about Elastos in this video. We're going to talk about why these virtual machines are necessary, what does a carrier do to provide and feed data across the network to preserve user privacy, to make sure people don't copy your data. I mean, that's pretty much what Facebook did, and they got into a lot of trouble for that. So all these questions will become quite clear after watching this video, and I hope you guys enjoy it. I'm here with Ron and Kieran from Elastos. And as always, we ask for a quick introduction about the project. So Ron, can you tell me a little bit about Elastos?
Elastos, actually, we call it a smart web powered by blockchain. That's basically the smart web is a new internet, it's a new web that runs dapps. And the smart web that run, instead of running websites and browsers, actually they're running virtual machines. And all the user IDs are issued from the blockchain. So all the messages are encrypted peer-to-peer from the website to the browser, from the browser to the website. And the hoping for this project is that we can build a new economy so that the users, the consumers can generate their own data, monetize their own data peer-to-peer and sell them. Ethereum has multiple virtual machines, but the Ethereum itself, like 6,000 nodes or 10,000 nodes of the Ethereum blockchain, they form a single world computer. That's like one computer running multiple virtual machines, correct?
Right.
And what we're saying is that we have virtual machines, like millions of virtual machines running on the internet, which is not really running on one specific machine. It's not running on a single world computer. It's running on multiple computers.
Right. And what's the advantage of running on multiple computers?
First of all, it's scalable. We cannot just say, okay, one computer fits all. That simply doesn't make sense.
So it's kind of like Siri, right? Whenever we access Siri, we don't compute directly on our phone, but instead we send it over to Apple, and Apple does the voice recognition, and then they do the instructions for us. So is this like what you're saying? In the future, we don't rely on one single piece of hardware, but the hardware interacts with other hardware to do the processing and computation.
Correct. The key difference of Elastos model from Siri model is that we have two things. One is we have a virtual machine. The virtual machine actually runs on your phone and runs in the Amazon cloud. One of the virtual machines running in the Amazon cloud, that machine runs some services, say Siri, voice analysis service in the Amazon cloud. Since that service is running in the virtual machine of Elastos, and Elastos, when you log into Elastos, whether you log in with your finger to a phone, and then that process actually behave with the identity of yourself. You logged in with you. So that instance of that virtual machine really is your virtual machine. It's not someone else's virtual machine with that identity. And then that virtual machine launches another instance of Siri server in, say, Amazon cloud. Still, that service has an identity, which is you. The voice analysis software is running on your behalf, right? And then that virtual machine is sandboxed because with your identity, that virtual machine can only access one drive, which is your own cloud drive. That virtual machine runs on your cloud drive instead of Apple's cloud drive, even though that's the same software service running in the cloud. So then the service cannot steal your private information.
Right.
Because when the service is running, it cannot save to someone else's cloud drive because they're always a third party. I, as a consumer, being the first party, and the machine, the virtual machine, being the second party, right? And the third party being a generic software, say doing voice recognition, doing deep learning, doing browsing, doing the social networking, right? So the third party software or services, the reason why we call them third party is because they're intermediaries. And in the past, the third party software has the liberty, has the freedom to access the internet. So when they run your data, they can actually make a copy to their own cloud. They give a copy to you and they save a copy. Right. With or without your knowledge, right? So that's where the privacy leaks happen. That's where so-called they brag about the big data because it's a free software, which is good. But on the other hand, they're really taking the liberty analyzing others' data.
But if we were to summarize this, I would probably say that Elastos is not really a blockchain project, but rather a network operating system project where blockchain is one component. Because blockchain is used to issue IDs to everything like the VMs that's running the users and everything, every device. And we have the another component, which is the Elastos Carrier, which takes over all the network traffic. And the other component is our Elastos runtime, where all the applications are run, where none of the applications actually have any permission to even go to the internet. So when you combine the blockchain piece to issue ID, authenticate, when you have these applications running in their own sandbox environment within the Elastos runtime and where the network traffic is taken over by Elastos Carrier, that's when you get the network operating system. So when we compare Ethereum to Elastos, it's really, I don't think it's fair to compare Ethereum to Elastos in that way because the Ethereum VMs actually run on the blockchain node. So any kind of smart contracts that you execute on Ethereum, they have to execute on every single node in order to reach some consensus, right? But the Elastos VMs actually run on the device, on the mobile device, on supercomputers, on Windows, whatever the case may be. These VMs are actually used to run the real decentralized applications, while the Ethereum, VM is actually only used to run the smart contract and that sort of thing. So that's where the difference lies.
Right, and because we're going to nitty gritty of this. So yeah, in Ethereum, every node runs the VM, so we can have consensus. But in here in Elastos, can you reach consensus with the code? Because if every machine is running a different code, how do we know that the code is being executed correctly?
Right. So to put it into another perspective, when I said Elastos is not a blockchain project, but rather a network operating system project, when you think about Ethereum, actually the blockchain piece for Elastos does have blockchain, but we have what is called the main chain, and then we have the sidechain architecture. Where main chain only handles the most basic stuff, like it only handles the transfer of ELA payments, which is our native token. And then as far as the smart contract capability goes, that is not up to main chain. Nothing gets executed on the main chain. Main chain only does what it does best to be, one trustworthy ledger for everything else. Whereas in the future, if you wanted to any of the smart contracts capabilities, they would actually be their own sidechain. So an Ethereum like smart contract could live in its own sidechain. When Ron was talking about an ID sidechain, that is actually just one of the many sidechains that Elastos on the Elastos system. There might be an ID sidechain which issues all the IDs, and there's going to be, let's say, another sidechain for Ethereum that only cares about executing these smart contract capabilities, and there might be another sidechain which takes care of the digital asset trading and ownership and all of that. So in that sense, you can think of Ethereum when you try to run any kind of applications on Ethereum. like we were saying, every application actually, as soon as you deploy a smart contract, every node on the Ethereum blockchain has to execute that, right? That's how you reach consensus. But what if an application that you're developing in the future, it does not require consensus of so many nodes because it is very computationally slow and it's not even needed? In that case, you could actually have your own sidechain on Elastos where you don't require all of those 10,000 nodes consensus. You only need maybe one of them or two of them or 6,000, 10,000. So that's where the difference lies between Elastos and many other blockchain projects. Because even we're not really competing with any other blockchain projects, but rather there's blockchain projects out there. They could actually act as a sidechain to Elastos. So that's where the thing is.
Right. So it's the main chain of Elastos is kind of like the accounting layer. It does only basic accountant transfer of value, and then the side chains would function as kind of the where you can start executing smart contracts or have kind of specific use cases, and it doesn't clog up. So you kind of like separate all these features into different side chains.
Exactly.
Well, you can think of it the other way. Actually, the Elastos main chain is more like the gold standard of this new economy. We're building the Smartweb. We're actually building a smart economy on top of it. And so you can think of, first of all, ELA has to have value. So then, in a way, it's like a gold standard because the miners has to be rewarded. Without the miners, basically, we need miners to give the illusion of the internet or the smart webs autonomously running. Right? Actually, nothing is really autonomous, automatic. The reason why the blockchain is autonomously automatic running is because of this miners, right? They're for profit. Yet the side effect of it is millions of those miners, right? Together, they kind of boost up the blockchain. So we use the Elastos joint mining algorithms basically to boost up the new smart web, boost up this new internet. So the key part, actually, the reason why we must have Elastos mining is we want to achieve this autonomous running, decentralize the new internet.
Right. And you're talking about, say, the smart mining. So Elastos is a joint mining with Bitcoin, right?
Yeah.
How does that work?
So the way that you can think of, I don't know how familiar you are with how I think Namecoin implemented something like this, where they merge mine with Bitcoin. But what merge mine means is you are using the existing Bitcoin mining machine. Your client software is the same, but then in addition, maybe there is some update that you might have to do on the software, where in addition to submitting the proof of work to the Bitcoin network, you're also submitting the work to the Elastos network. So in that way, you're actually using the existing energy and existing hash power of the Bitcoin network to also secure the Elastos network. So in that sense, even if Elastos does, have proof of work for its main chain, now sidechains can have their own consensus like POS, DPoS, whatever. But the main chain actually merge mine with Bitcoin. What that means is, without using any additional energy, it can just piggyback on top of the existing energy that is already being utilized by Bitcoin. So why not just use the hash power, the huge hash power that Bitcoin provides in order to secure this new smart web that we are creating? So that's where the idea of merge mining comes from.
Got it. So you're kind of you're leveraging the enormous hash power, because Bitcoin has the highest hash power and it's the most number of miners. So probably the most expensive coin to mine. So you're kind of piggybacking on that and getting protection, that the Bitcoin level of protection for proof of work, and you're having a proof of work mechanism as well. So that's what you're trying to achieve. But does that require, say, the clients that are mining Bitcoin to run a separate client? So that's Elastos plus Bitcoin, the SHA. So you're still using SHA-256, but just a different client, right?
Yeah, so you would just be updating the software. So in addition to mining Bitcoin, you're also mining ELA. So another advantage to using something like merge mining is the same level of trust, the hash power that we get from the Bitcoin network can actually be passed down to not just Elastos, but also any of the sidechains that decide to merge mine on top of Elastos, so that in the future, like with Bitcoin, every 10 minutes a block is mined, right? Mm-hmm. But with Elastos, a block is mined every 2 minutes. So in the future, like you might have a sidechain that wants to utilize this existing merge mining capability on Elastos, so they could utilize that. And so they would be piggybacking on top of Elastos, which is then piggybacking on top of Bitcoin. And so using that sidechain, it can be used to power many different kinds of applications using the existing Bitcoin hash power. So that's the one of the advantages of merge mining. And also, you don't need to reach consensus on all of the nodes as evidenced by like how Elastos merge mining works. Let's say in the future, a sidechain just requires, just to test it out. You just want to get started, right? Just to merge mine your own application, your smart contract, whatever. You can just start with one of them, like one node, right? And then if you get popular enough, if you need more extra security, you can increase that to more. And just by doing that, even if it's just one node, like merge mining, it is still using the existing hash power of Bitcoin network. So in a way, it is still pretty secure, but that level of trust can be passed down from Bitcoin to Elastos to any of these sidechains, mm-hmm. that can then be used to power any number of applications down to the application level.
So one aspect about Elastos on top of mining is the carrier aspect of communication. So it's computation and network. How does the Elastos Carrier work?
So Elastos Carrier, it's a decentralized peer-to-peer network, which means that all the applications, all the websites that are going to be running on Elastos won't really have any IP addresses to begin with. Instead, they'll have a unique ID that is recorded on the blockchain. So then, and then we also said earlier that applications have no direct access to the internet. Well, how else would they be getting data from the internet if applications can connect to the internet? That's where the carrier comes in. When the applications want to, get any kind of data from the internet, what they do is they actually they contact the carrier, and then carrier then takes over. It sees like, oh, what do you want, application? And application is like, hey, I want this data that belongs to this hash. And so what carrier is going to do is it's going to go, it's going to go to different nodes on the network, and then try to look at where the data is stored. This data might be stored anywhere, and so it gets the data and then passes it back to the application. So in a sense, we completely disable these traditional HTTPS protocols, so that it's very hard, if not impossible. I wouldn't say impossible, but it raises the bar when it comes to a lot of the distributed denial of service attacks and man-in-the-middle attacks. Those kind of things should be very, very difficult to do because carrier takes over all the network. Like even if some middleman were to hijack, some server for some data, well, what are they going to do? They don't know where the data is stored. So there is no incentive for them to even hack into the network. And even the data itself is, because it is decentralized, it might be stored in one of the nodes from in my own house or in the other side of the world. We don't know, because of these virtual machines make that possible. There is no distance. The only thing that carrier cares about is how to get that data, and it gets the data by checking all the nodes, and then it gets back the data. So a little thing I wanted to clear up also is with Elastos, there are actually two kinds of nodes. One of them has to do with the blockchain node, the mining node, where the miners are actually mining, merge mining Bitcoin with Elastos. And then whereas another kind of node is called the carrier node. And these nodes are actually what's going to enable the traffic of transferring, communicating between different virtual machines, different people, different devices, all across this new internet that we're building, new Smartweb. So that's where the carrier piece comes in. When you talked about Ethereum application, they're actually we consider them actually not completely decentralized, because the only thing that gets that gets executed on the blockchain piece is is the DNA of, like, let's say if you take an example of CryptoKitty, only the DNA, the transactions bit, that they're the only things, and the smart contracts bit, they're the only things that are using the blockchain nodes, right? Everything else, there's still some server that it needs to connect to. And so when you have a centralized server, well, what if the server goes down? Your application, even if it is utilizing, this blockchain Ethereum, if at the end of the day there's no way that you can store these huge movies and games and all that on the blockchain, there's still some central database, central server that these applications are storing. And if that server were to get hijacked because of these, there's a fundamental flaw in the way that the old internet works. It's very easy, and it gives hackers incentive to actually hack into these central servers, and that's how most of the privacy leaks happen. We're trying to address that problem by making everything decentralized, not just the miners bit, but also the peer-to-peer network bit. So even your movies will be stored on a distributed network, similar something like IPFS, so that even if a hacker were to try to get your hands on whatever user data movie, they just couldn't, because it is distributed and it's really next to impossible to do so.
Unless you hit the carrier, right? Unless you hit the carrier, and unless the hacker has your key, in which case then they can access that because the carrier will help them.
Right. The carrier requires, in order to even get the data first, the ID of the user, the ID of the applications that is requesting it, everything has to be authenticated first, and all of that is recorded on the blockchain, right? And even if these nodes are communicating with each other, which they do, the only way to decrypt some data would be using your own private key, public key pair. So if someone were to get your hands on your private key, well, that's another issue. But as long as that is secure, your data should be secure.
Right. So the carrier is what really allows for the communication, and allows for this virtual switch that cannot be really tampered with, right? This virtual circuit that connects machines together. So with all that design in place, what's the current status of this project?
We are going to release the Elastos Alpha by the end of August of 2018. Mm-hmm. Basically, we're releasing it by the end of this month. And that said, we're going to have this, of course, we're going to have the blockchain issuing IDs, the decentralized IDs. And on top of the decentralized IDs, we'll have this carrier. As I said, Elastos actually is a collaboration of multiple computers instead of one world computer, because everyone is entitled to have their own computer, virtual, right? And everyone has a virtual computer, whether it's a person or corporation or a government, large or small, they're all virtual computers, peer-to-peer, right? Because one phone comparing to great supercomputer, there's still two computers. And so in a way, carrier is a key to have the communications between multiple computers. And the prototype of it is open sourced already. And by the end of the month, we'll have decentralized IDs and carrier with this virtual machines. And the virtual machine will be the new kind of browsers and macro websites. Mm-hmm. The reason why we call it macro websites is because that's websites without IP addresses. So the IP address, the websites could be built off your homes, peer-to-peer, right? So you can think of your smart router and powerful enough to be your personal cloud drive or your home server. And then your phone could log into your home server and access your surveillance camera video. That kind of demo, the personal cloud drive demo, we call it DitoBox. It's open source. And out of the DitoBox, we build macro websites. And out of the macro websites, you can have a personal smart web browser. We call it Elastos. You can install the Elastos browser on your iPhone. You can install it on your Android phone. And the difference between the Elastos browser and the existing web browser is that we don't let applications running inside browser to access the internet. So no more IP addresses accessing the web. You have to go through the localhost hash. Then you can get onto the internet through carrier. And we all have the browser, a very simple one with some demos and playing some music, playing some short videos by the end of this month. So don't keep your expectations too high. This is just a alpha versions of Elastos, but yet we have high hopes because of this. We're literally showing a new kinds of a smart web, a web that runs apps, the web that runs sustain the smart economy, which is completely novel and a new thing on the horizon.
That's interesting. So in terms of the kind of release, the alpha will already contain an application on our phones that would immediately access the Elastos web, and Elastos will start already offering content already, so you can start seeing videos and already with this new way of communication and with the virtual machines.
Correct. It's more, as I said, don't keep your expectations too high. It's more like a browser in a way. It's like a window to the new frontier.
To add on to that, the alpha version, we're trying to publish that by the end of this month, which is the end of August. So what that means is everything that we've talked about today, the runtime, the blockchain, the sidechain, the carrier, the runtime, everything we've talked about today, it's already open source, and everything will be incorporated into that alpha version. Again, this is an alpha version, so it's not like people can start downloading just willy-nilly from the App Store. It's more geared towards developers, so that we'll also be providing the SDK for developers to build on. So after the alpha version, people should have a clear idea, and developers especially can actually start building their own applications. And then by the end of this year, which Rong mentioned earlier, or early next year, which we're planning to go beta and then into production. So right now, everything that we've talked about should be live, and it is open source. Anyone is free to take a look. More documentation will be provided, but it's a new opportunity for developers to come on board and actually build a real decentralized application utilizing the.
I want to emphasize one is when people talk about transfer of value, because when you talk about blockchains, a lot of people are saying. The old internet is the internet of information, and the new internet is the new internet of value, right? And then people talk about transferring value peer-to-peer. And literally they mean by transferring Bitcoins or other tokens peer-to-peer. What I'm trying to emphasize is that the digital assets not only includes tokens, they also include other digital assets. Other forms of digital assets, for example, ebooks, movies, games. So when we form the digital economy, you give me a token, I give you something in return. That's called a smart economy. And so when you transfer tokens peer-to-peer, can you transfer that digital assets peer-to-peer? Correct? And most people talk about, okay, I transfer value, I transfer the tokens peer-to-peer. They forgot to mention, can you transfer the digital asset peer-to-peer? When you transfer a Bitcoin peer-to-peer, literally, the reason why you're so confident because you have trust in that ledger. You don't have trust in me. You have the trust in that ledger.
Yeah.
But then when you transfer me another forms of digital assets, for example, movies or games or ebooks, do you have confidence that whoever has the interpreter of that, the media player of that movie. If you don't, then you cannot send me the digital assets peer-to-peer. So what I'm reasoning is that transfer of digital assets, really you have to transfer code. You have to transfer the confidence behind the code.
That's very interesting. I mean, so it's a two-sided verification, not just on my client side, but when I download something, it verifies that my client is also authenticated and is secure. Ron and Kieran, thank you so much for coming on to my channel, and I hope to learn a lot more about Elastos. I think this is a very, very big project, much like a super grand vision for a project, and I hope the alpha goes well, and also of course you can come back and we can talk more about how we're going to decentralize the internet.
Well,
Awesome.
okay,
Thank
thank
you
you
for
for your
having us.
time.